My name is Toby Bond. I'm an industrial scientist at the Canadian Light Source. I've been working there for over 7 years. And so my job is essentially working with private sector clients of the Canadian Light Source who come and want to use our tools to solve kind of applied science and engineering problems. The Canadian Light Source is Canada's synchrotron facility. We operate a very large research program there. And the synchrotron is essentially a large facility where we accelerate subatomic particles. In our case, we use electrons. We accelerate them in a ring, like a big racetrack, very, very fast. So very close to the speed of light, which is the fastest anything can go in the universe. And when you do this, one of the effects is it generates a really, really intense beam of light. And not only the kind of light that you see, it also generates things like ultraviolet light, infrared, X-rays, everything on what we call the electromagnetic spectrum. And so it's those kinds of light that we're more interested in, especially X-rays. And we use that kind of special high-intensity light to do science. So we, at the end of every experimental station we have there, there's a beam of light and there's a sample. So there's some object that we shine the light on, and we take pictures of it. We'll use it to understand what's happening in terms of the chemistry or the structure of the material, and so it's very much an applied science kind of facility. We have a particle accelerator, but we're using it to do science and understand what's going on in real-world materials. So I grew up in Saskatchewan, just outside of Saskatoon. And when I was going to school at the U of S here in chemistry, the synchrotron was being built kind of off in the distance, and I'd heard about it a little bit as I was going through my undergrad. And I don't think I realized until I went there and started doing work, and especially until I graduated and started talking to researchers from all over the country, how big of a deal it was. Everyone was really excited across the country that we had a synchrotron in Canada, let alone in the city where I already grew up. So, when they built the facility, there weren't exactly synchrotron experts in Saskatoon. So we brought in people from all over the world. When you walk down the halls, you'll see people from a variety of backgrounds, from different technical backgrounds and cultural backgrounds. So it's a really unique place to work from that perspective, and it's kind of a focal point for researchers to come to Saskatoon, and I think that's really enriched the environment around here. A type of work that we do a lot in Saskatchewan is I mentioned working with the mining industry, mm-hmm. And so they have when you build a mine, you'll generate some kind of waste from it. They call this waste tailings. And one of the kind of more difficult aspects of operating a mine is making sure that you can deal with the tailings in a way that's going to have a minimal impact on the environment. We'll help them understand the chemistry of certain elements that are really important. So things like arsenic, for example, that are of concern. They need to make sure that arsenic is going to be well behaved, that's going to stay where it's supposed to, and it's not going to get out of the facility into the surrounding groundwater, for example. So something that we can do at the Canadian Light Source is we can zero in on specific elements, and we can look at what's happening in terms of chemistry just with that element, which is a very difficult thing to do otherwise. So we can look at something like arsenic in a very complicated sample like tailings, which is full of all kinds of different elements and all kinds of different compounds. And we can just say, all right, what kinds of types of arsenic do we have? Are they going to dissolve in water? How toxic are they? You get a lot of information that really gives them the wherewithal to manage that facility properly. So we built the synchrotron was commissioned in 2005, so we've been operating for a little over 15 years now. That puts us kind of at maybe midlife in terms of how synchrotrons operate. And so in the next few years, we've just finished a bunch of major upgrades, and we're starting to build kind of the last of the facilities that we were originally planning. And so now we're actually starting to look at building a new facility, building a new synchrotron, at least starting the process, because it's a very long process of getting the funding and approval to build a new facility. So we kind of have built a lot of what we want to build already, and over the next kind of 5 to 10 years, we're going to put all those new facilities to good use. But already we're starting to kind of have an eye to the future and what we want to what we want to see in a new facility. Other countries around the world are already starting to build their new facilities, kind of the new generation of synchrotrons. So I'm really excited. It's interesting to be part of that process. Really excited to see what that might look like, and how we might be able to improve on the facility we have, which is already pretty great.